Thank you very much. Good afternoon. My name is Simone Severini, and I will be chairing this workshop that is very rich. We have many distinguished speakers and panelists that will cover this topic, which is the digital transformation of the farm sector. So we will go through different aspects of digital transformation of the farm sector, but also we will focus on opportunities and challenges for higher education. As you know, we are a department within the University of Tuscia, which is located in Viterbo, Italy, and our department is specialized in agriculture and forestry sciences. I have not very much more to say. I just remember that at the end of the presentation, there will be a discussion section that should start at around 5:15 p.m. And so you can interact with us, also posing questions using the question and answer procedure of the Zoom program. And you can see at bottom at the bottom of the screen with this section. So we have room for posing questions to the panelists, and we will discuss all these questions at the end of the workshop. So I have not very much to say more, and I will leave the floor to Raffaele and then to Raffaele Casa, who organized together with Umberto and myself this workshop. And then we will leave also the floor for opening speech to Nicola Lacetera, our department head. So Raffaele, the floor is yours.
Okay, thank you very much, Simone, and welcome to everybody. And also, I would like also to thank very much the speakers who were available to participate to attend this meeting. This meeting is just very few words to say that it's just a meeting organized in the framework of the project of excellence of our department, and in particular in the work package number 6, which is about agriculture 4.0 or digital agriculture, precision agriculture, whatever you might like to call this topic, which is dealing in general with the introduction of technology, digital technology in agriculture, but also we talk about agriculture, including also the livestock farming sector, as well as also forestry sector, because our department includes also these areas. So I will just leave the floor to Nicola, to our director, and I will summarize a little bit the research lines of our department in this area, in these topics at the end of the discussion of today. Just I will make a short presentation later on. So for the moment, it's just a few words to say what the workshop is about. Okay, so please, Nicola.
Thank you, Raffaele, for giving me the floor, but above all for organizing with Simone and Umberto this workshop. And then let me join you to warmly thank the speakers who accepted our invitation. So as you anticipated, I just want to give people a more precise idea, even very shortly, about the project of excellence you also introduced with your talk. The department which organized this workshop is the Department of Agriculture and Forest Sciences of the University of Tuscia, the acronym of which is DAFNE. And in the department is a teaching and research community which includes about 60 people belonging to the academic staff, and covering a wide range of research themes and topics within the areas of agriculture, forest, and natural sciences, and also on agri-food and biotechnology. We have also a number of people belonging to the technical and administrative staff, about 30 people, and we have a number of laboratories and an agroforestry teaching experimental demonstrative farm very close to the department site. Well, in 2017, the department was placed in a list of 120 Italian departments which were classified and which were included in the list on the basis of the quality of the research carried out in the previous 5 years. And this achievement made the DAFNE able to get approximately 8 million euros as extra funding, which will be used in the period 2018-2022 to carry out and to realize a project of research and teaching improvement titled Sustainability of Mediterranean Agricultural and Forest Systems in the Context of a Global Change, the acronym of which is SafeMed. Well, this funding are being utilized to improve in terms of number of people, the personnel, basically people belonging to the academic staff. Money are being used to improve infrastructure, equipment in classrooms, etc. And we have also money, and we are also spending money to increase the number of PhD students, such as the number of postdoc students. And we also have money for implementing the people and students deciding to spend part of their formation abroad within the Erasmus project. We have money also to organize workshop, but we use this money during the first 2 years of the project for covering travel expenses and accommodation of speakers we invited, but due to the COVID emergency, we have not been able to host people at our site over the last 1 year. And we also are using this funding to organize summer courses, the first of which will be organized in the next June. Also, the summer courses activity were affected by the COVID emergency. Well, the research carried out within the department, and which will get the benefits from this extra funding, cover 6 main themes, and within which of these 6 themes there are a number of several topics or tasks, if you prefer. And the main production chains covered by the project are cereals, olive, nuts, viticulture, horticulture, and dairy ruminants. Well, very shortly and very briefly, a list of the 6 work package the project is organized, each of which has a number of different tasks. The work package number 1 is on nature, forest, and sustainable use of agro-silvopastoral ecosystems, with a number of different tasks. The work package number 2 is on agriculture and forest systems and climate change, and also in this case we have a number of tasks covering the themes of crops, livestock, forests, etc. The work package number 3 is on innovation in the agriculture and forest sector for energy sustainability. Also in this case with a number of different tasks and with a a number of different people of the department working on them. The number 4 is on valorization of agriculture and forestry production, considering mainly the qualitative aspects. And as you see, this work package is very rich because we have a number of different groups working in these areas. The number 5 is on biotechnology, agriculture, environmental biotechnology, covering plant, animal, and agro-industrial biotechnology. The work package number 6 is the work package within which this workshop is organized, named Advanced Agriculture and Forestry Technologies. I don't have too many things to add to this presentation, apart from the fact that these areas are also the areas our bachelor and master courses are devoted. And so the last slide is a slide which include all the principle of word cloud with the main words you can find within the project. Thank you very much for your attention, and I hope you to enjoy the workshop and to and let me say that I hope to have the chance soon to have the hosts and the speakers in our department to have more occasions for an interaction. Thank you very much. Thank you very much again.
Okay, thank you very much, Nicola, for this overview. And then we can start, and I will leave the floor to Professor Bruno Basso. Just you word, he's has a background as an agronomist, but with more than 20 years of worldwide experience in precision agriculture, crop modeling, and land use sustainability. And he's also a professor at Michigan State University, from which he is giving us his speech. So, Professor Basso, the floor is yours. You have 20 minutes for your presentation.
Thank you very much, Simone. Can you hear me well and see the screen okay? Okay. And well, I'll also like to thank Raffaele Casa, who invited me to present some of this overview and briefly the critical points of where digital agriculture is really moving forward in the US. And I had the opportunity to introduce towards the end of the talk some data about South America, given the fact that my co-author here, Susanna Albarenque, is a PhD student in my lab, has been doing some of that survey analysis about digital agriculture in Argentina. The point here to make is why do we have technology and innovation, and why do they move forward quickly? And it's pretty clear that they have to improve things, improves conditions. And conditions can be the way people live their lives, the way the environment works, or the direct people involved, for example, the farmer improving conditions in the sense of economic conditions. But they come with a trade-off. So there is a cost, there is complexity, there is tradition and barriers in adopting this technology. But despite the fact of the complexity of the innovation in agriculture, there is truly a digital revolution happening. And here are just a few quick snapshot of major press articles. I mean, we will never really see much of the coverages of the future of agriculture in high-profile magazines like Nature or interviews on Forbes. But one reason is that this innovation is also coming along with some appealable tools. These fancy robots or very useful technologies at the moment, like this completely automated irrigation system that you see in the lower bottom, or spraying drones with high efficiency. just to walk you through, we're not new to breakthroughs in agriculture and innovation. Briefly, in the early century, the previous centuries, we saw the mechanization that obviously it allowed us to expand the lands of agriculture. That didn't come with a price. They came with a significant amount of environmental impact. The Dust Bowl in the US is one of the consequences of extensive tillage and soil not be covered with crops, and so erosion, both wind and water, caused a significant soil losses that actually allowed the US government to develop the first soil conservation service as a response of that event. Later, fertilizers, or in general, I would say more agrochemicals, have allowed to increase yield production, and that also didn't come with all just positive things, because there were a severe environmental impact that we continue to witness in water quality. Biotechnology, we all know the progress being made in selective breeding and more advanced breeding, some even conventional, but with the genetic modified organisms, all the way to be able to with CRISPR technology, having very precise target cut in the genomes of the plants to be able to have the desired traits always be present. In just starting a few years ago, I would say in the 2010s or so, we had this revolution in data science, the possibility of, it really happened when all the public information became, with quality check, became available, mainly the soil data in the US as well, the climate. We now have about 800-meter resolution weather every 10 minutes until about an hour ago. That is publicly available in the US, and the same in Europe. And so the technology there that you see listed, satellites, they're going through an additional level of innovation, what we call digital twins. I don't know if you have been exposed to that terms, but that terms is really much more used in the engineering context, but let's define it. It's really more the bridge between the physical and digital world, where things are basically designed and in a virtual model to simulate the process, the product, and the services. And so with this, this is an example of things that we've been doing for quite a bit of time, the simulation of plants using the crop simulation models on the computer, transforming process-based mechanistic approaches of growth and development of plants into a computer, and they get better and better, both with the advancement of the sciences as well as the improvements in the input. But what I refer here is really linking synthetic biology with sensors and system approach, and so things are very much designed on in a virtual system before they're implemented, and you'll see some example of that. So one of the projects that we have recently submitted is really to start using the most fancy way of sensing the environment, whether it's to sensing compounds, volatile compounds emitted from plants under a different level of stressor with micro GCs mounted on drones. One other example is implanter sensors or nanosensors that basically can detect exudates from microbes. And so there is quite a bit of innovation in basically including making plants become the real sensors rather than the sensors within, mounted on the plants. For example, having the plants and the genetics to allow to turn one of the leaves in a different color in response to some level of stressors. So this is still on the working prototypes. The advancement made in technologies at a scale of pretty much unimaginable, few micro meters, and with electrical tomography, you can see clouds and start seeing where carbon gets basically stored and accumulated. So there's quite a bit of advancement in that. If we move, mostly our agriculture is really seen, when we talk about precision agriculture or digital agriculture, we envision much more the field conditions. And so quite a bit of progress has been made in that by analyzing images, for example, canopy temperature. That's an example of canopy temperature of an apple tree stands with a strong correlation with presence of diseases. So this is our drone flying over with a LiDAR, and as he flies, detects, you know, canopy sizes, and or detecting digital elevation models with additional layers of information and 3D of plants with historical images and images over time and calculation rate of changes. You start inferring about the impact of a particular interest treatment. So going more into the mainstream, let's say, agriculture, where I'm located in Michigan, and in the Corn Belt, you'll see, just to give you, you know, perspective, and as you're all very familiar, I mean, this is truly the basket of, you know, corn production, and also with the level, the blessing of these areas is that you can grow about 14 to 15 tons corn without irrigation. So it's truly basically a blessed 2 meters of dark soil, stored water, beginning of the season, and pretty regular distribution within the season, even though with increased climate variability and change, we're witnessing quite a bit of changes in erratic pattern. But it was measured with fluorescence that the Corn Belt basically outproduces the Amazon in terms of productivity at the peak during the summer. So some of, you know, we went from nanoscales to all the way to the possibility of be able to detect changes of yield. That's the map up on the left corner is a yield map over time. And you can see corn after corn is typical in many of these places. The possibility of looking at changes over space and time has allowed us to develop a truly scalable approach of these fields. And so you can now click on any of these fields and be able to know which areas that are constantly doing well versus areas they fluctuate from one year to the other, and which areas they are basically constantly underperforming. That can be done also with thermal stability. And the interesting thing is that variability is not pedocentric. So it's the same soil type, that it does not give always the same yield, given the interaction and the complexity between land position in the landscape, climate, and management, and so on. The other interesting thing, as we said, profit is what drives innovation and adoption. And so we're seeing that thanks to these approaches, we can quantify now on a large scale the areas where the farmer is basically losing money. And you'll be surprised how much of that is present. And many of the farmers actually weren't, I always say, they weren't ready to see this sorts of analytical tools, especially scaled. So from yield stability, which we introduced this profit stability analysis, you basically see areas that constantly lose money up to $200 per acre, which is a significant amount of losses. Why are they still in business? Because here the incentives are provided by the acreage of corn, not for ecosystem services like often done in Europe. So they basically compensated with a buffer, with a threshold, and so it doesn't really matter. It's really counterproductive to it's absurd the way, you know, incentives are given at the moment, because again, the environmental aspect is not accounted, and luckily this is changing. So again, one at the core of the analysis, profitability can allow you to get enhanced biodiversity, and with variable rate, you get better environmental impact. So this is the example of profit analysis by zones, you know, high and stable zone being more productive, others being constantly underperforming. And so we have a very good understanding. And so there are a few papers coming out of this to show how much some of this land is really not gifted and could bring better biodiversity ecosystem services. One of the things, I know I'm really short on times, but there is quite a bit of advancement in more climate responsive. I don't know if we can see this. You see the video? So electrification.
No.
No?
No.
Okay, no, never mind. The reason you don't see it is because I did not share, but I need to get rid of the music. Okay, there was a video, just pretty impressive changes done in John Deere with electrical tractors and robotics. So let's go now to some of the analysis and the milestone done in agriculture, a little bit of history. You can actually read it from this paper that came out a couple of years ago. But, you know, going from the presence when the US government allowed to have, you know, moved the delusion of precision and allowed to have GPS on tractors. From that, it was really a milestone to allow for everything else to be put it on tractors and sensing variability and so on. So this study showed the level of adoption, and you'll be surprised to learn that basically in 2016, 68% of the farms in the US had in maize had yield monitor. 45% of that was yield mapped and basically visualized. What you have seen though, in addition, I personally have a very large data set where we tested the yield stability analysis. So the spatial extent is no longer much of a limitation because of remotely sensed imagery that cover the entire territory. But for what concerns the other technology, variable rate technology, the possibility of spraying different inputs across the field, it's coming up, but it's still behind. And in the US in maize, 29% of the farms implement some sorts of variable fertilizer application and soil mapping. So I'll go quickly through some of this. US is not only one. Argentina has a significant amount of adoption as well. And again, for time constraint, I'll invite you to read that particular paper, because I would like to focus much more on the analysis done with the growers and their responses about the complexity and what actually is needed in terms of educating both, you know, the farmers and the people that provide, you know, these services. This is just an example of the application in the US of variable rate. The most widely used is lime application for correcting for pH, and there is, you know, variable nutrients and multiple applications. So basically, it's certainly a reality. In terms of sales, the dealers that have technology, most of the sales are stable in terms of tractors and having guidance, automated guidance. The percent of dealers that allow and present, you know, the possibility of using a service, it's on the single nutrients, it's still in the 50%. So even if you don't buy, the dealers could help support some of, you know, this implementation. For what concerns Argentina, again, back on the sales, there is large amount. I know these numbers are very far from what we're seeing in Italy. Italy is obviously characterized by a quite distinct level of agriculture, but we do have areas that somehow resonate, both the Midwest, you know, like obviously the Po Valley and some of the plains of wheat growing areas could suddenly adopt this technology in terms of, you know, digital agriculture. All the other innovation at, you know, horticultural fields, it actually, because the payoff are much higher, they can still be implemented. So this just to show some of the results of these surveys and the feedback from the farmers in the context, again, of what you are organizing here, trying to discuss about, you know, training. What the farmers were all in Argentina with the survey, they were all aware, both in 2013 and 2018, of the presence of this technology. So GPS, yield mapping, monitoring of planting, automatic pilots, parallel guidance and variable rate. So they were really informed. Drones came out later, and about 70% of the farmers interviewed were aware of drones providing some input. What was the main barrier in their adoption was that the cost of technology was still high, and capacitation is really training. Training is limited, and they basically the whole industry lacks, training, and they get trained by the industry and not as much as we do at the university. There are programs in the US that are strictly on digital agriculture. They're becoming, more popular, but training plays a critical role. How do they use it? Why do they use it? It's because it decreases the cost of production and increases the environmental, the profitability, increases yield, increases quality detections, and better management of the whole fleet of tractors. And so there is a positive response. I mean, these people were obviously very well aware of what was going on. Let me just conclude by saying that the AP utilization is highly related to the farm sizes in Argentina, not necessarily in the US, because in the US there are services provided, as I've shown, by the retailers that could provide the services. So not all of them own the machinery to do variable rate. But here, I'll wrap up soon. Actually, the possibility of managing these large farms and being in precision ag for more than 10 years, it was really driven by the sizes of the farms. And the technology came mostly from the research institution, INTA, equivalent of our, Ministry of Research, I guess it's called CREA now. But university is coming on board. It took much longer for the university to implement some programs. As we know, the ministry don't have, teaching loads, and so maybe they could have more dedicated programs. But university is coming on board and starting to deliver information. The data that they process mainly is yield mapping. That's the thing is much more identified, but images from satellites is becoming extremely important. So 80% of the number, and it's a pretty extensive surveys because these are large farmers representing, I don't know what acreage, but it was mentioned to be pretty large, but 80% start using digital, images or some other kind of photographs. What is most commonly used is basically visualize, delineate management zones, guide sampling, and generate prescription maps. That's how it was used. What are the limitations? First one is training. Training of people is limited. They wish to have more. Better, specialization, be able to be trained to how to handle data, how to process data. And often they face incompatible software when a data from one provider gets into another. They would like to see more training, better agronomic information. The engineering, it's still a little bit ahead of the game in terms of, it's a man-made system. The agronomic is much more complex to design this prescription, but also be able to have many more of this sorts of, type of conversation with farmers can learn more. And so they were demanding for better exchange of information. I'll stop here. You can see from my messages that technologies is pretty much unavoidable and unstoppable. I mean, as you know, in many other sectors, and education needs to keep up the pace and the request from the industry, because we currently are doing a partial job on that. And with this, I'll stop, and I'll be happy to answer any question you may have. Thank you.
Thank you very much, Bruno, for this very inspiring and very, very rich presentation. Too bad that we have not enough time to go through And it sounds very interesting for us that, you know, there is the need for give impetus to education and program. And so I hope also the young people and students attending will take the message and take home message. That's an important area for development and future activity. Okay, so thank you. Now is time to switch to Fabio Abeni. If you are ready, Fabio.
Yeah.
In the meantime, I would like to say that now we switch to livestock precision farming, and Fabio Abeni is the Director of Research Centre for Fodder, Crops and Dairy at the Council for Agricultural Research of Lodi, Italy. And of course, is an expert in animal science in general, but with emphasis in animal production and nutrition, especially in dairy, and of course in livestock precision agriculture. So Fabio, the floor is yours. You have 20 minutes for your presentation.
Thank you. Good afternoon to everybody, and many thanks for this invitation to your department. Today I will show you some suggestions about precision livestock farming, the main challenges to catch the opportunities. Briefly, first I will show you some new challenge, in my opinion, the new challenge for a young animal production scientist. The main challenges due to the availability of precision livestock farming tools. Now we have the, sorry, one moment. Okay, we have the opportunity for new approach to animal biology modeling. We have new opportunity about phenotyping, about large-scale phenotyping of many animals, because livestock precision farming allow us to obtain data on higher number and for a long time on the same animal, large number of data. I want to show you some suggestions about the worm farm data management that give us some informatic issue that we must solve, and also statistical issue that the young scientists need to face. We have new possibility about animal farm modeling and a new look at animal farming management as an integrated body within the whole animal production chain. Then I will show you some suggestions about the relationship between the opportunity due to PLF availability and economic sustainability for efficiency, product quality, environmental sustainability, waste management and emission reduction, and social sustainability, mainly as animal welfare and health issues. First step, the opportunity for animal modeling. In the recent past, the main approach of our scientists about animal modeling was a mechanistic modeling approach, where causal pathway analysis and decision support tools within animal production system give us the opportunity to create a model to generate information and to translate this information in the practice rather than in other science work. We quantitatively define how a biological system works, and this was based on causal relationship, and then the use of that cumulative biological knowledge to generate prediction and recommendation in practice on farm level, and to generate or evaluate our hypothesis in the research field. But this approach had some limitation. It was necessary to obtain sufficiently accurate inputs that we need to put in the model, a specific training for the user of this model approach, and it was necessary high accuracy and precision of prediction on farm level. Now we have the possibility, young scientists have the possibility to move to a data-driven model approach. Data-driven models are related to the use of machine learning techniques, deep learning techniques. With this approach, we examine patterns in data to produce accurate prediction, for example, forecasting, classification of animals that can be better managed in a different grouping strategy. And this way, the sensor data and the new self-learning modeling techniques may address some limitation of the former approach with mechanistic model. But we must keep in mind that also this approach may have some limitation because most of these new methods, for example, lack transparency in the reasoning behind prediction, in contrast to mechanistic models that have historically been used to translate knowledge into wisdom. Practically, sometimes we obtain very spectacular results in terms of prediction, but it is necessary to perform further steps to really understand from an animal modeling point of view which are the reason of the attained result. So this is obviously a new challenge. And this is a picture for a comparison between these approaches. The traditional, based on biological principle, with a mechanistic approach, where learning type was the developer provided, and the new challenge, where models are based on prediction accuracy, or data-driven, with supervised or unsupervised learning approach, with different problem type, regression, classification, clustering, rather than dimensionality reduction. Another important challenge is the possibility with PLF for a large-scale phenotyping of farm animals. I propose you the case, for example, for animal welfare genotyping. To approach the animal welfare case, it is necessary to attain a longitudinal measurement of multiple welfare indicators. This is the main requirement for a really selective breeding to enhance animal welfare. So this way, we must define, first of all, our phenotypes, what we want to measure, which kind of phenotype we want to measure. Phenotype as a variable that can be measured on a continuous or categorical scale in individual animals and represent a biological mechanism at a certain time point or life stage, because the animals can be subject to different degree of challenge for their welfare at a different stage of life and different physiological stage. So we must define resilience as the animal capacity to be minimally affected by disturbances or to rapidly return to the state attained before the exposure to a disturbance. And this approach can also indicate welfare. Therefore, it is necessary to identify resilience indicators that we can measure. Generally, we define resilience indicators as deviation from the expected production level, for example, over a period of time, or variation in automatically recorded feed intake. This because production on one side, but on the same side, feed intake are two faces of the same object, the response of the animal to the challenge. PLF give us some possibility. For example, first, the possibility for a continuous monitoring of the animal welfare state, sometimes from birth to slaughter or involuntary culling. And this is needed because, as I suggested before, the animals can be more or less prone to certain welfare issues at specific life stage or physiological stage. PLF gives us also the opportunity for the recording of a large number of variables. And this is needed because we want to accurately measure individual animals for their biological indicators of the respect of the 5 freedoms. And third, PLF gives us the opportunity for a data collection based on non-invasive methods that do not result in additional stress to the animals or may alter their routine or circadian rhythms. Sometimes with traditional animal welfare approach, animal welfare measurement approach, sometimes some methods themselves can affect the welfare state at the time we want to measure animal welfare. And PLF give us a big opportunity to avoid this bias. So we must define phenotype that has to be collected at a low cost, obviously, to enable measurement of a large number of animals for a successful implementation of genetic and genomic evaluation. This is an important opportunity, the ability to reduce cost of measurement. And our phenotypes must be identified as heritable and repeatable. Otherwise, we can identify alternative variables that can better capture the genetic variability for the traits of interest. About World Farm data management, our young scientists and technicians now must face some informatic issue. In the traditional curricula of agricultural scientists, generally the engineering expertise is present, but in a different extent and generally not with a big share in the curricula, because the biological expertise is more characterizing our sector. Now young scientists, young technicians need to be able to face some engineering aspect, especially namely for the first three steps of an approach to design a smart farming system. They must know something about sensors and actuators. They must know something about the possibility to connect the different sensors, the different sources of information, and how to manage in the best way the informatic design at farm level. And they must be able to know the possibility to link with the web, with the cloud, and the service on cloud. The final step, the fourth step, obviously is more traditional for, is obviously a new challenge, but is more traditional in our expertise, expertise as agricultural scientists. Is the step where we use application, we use a decision supporting system rather than analytics of time series, model identification, and so on. And if young scientists will be able to match this new opportunity, these new skills, they can actively participate to build a smart farming based on each of the 3 layers of a smart farming system. At the bottom, the Internet of Things project. At the second level, the edge level, with the ability to select the best strategy for local data store rather than local data computation. And the third layer, connecting to the cloud for business solution for computation, analytics, authentication, and so on. Another important issue is that related to the statistical approach that our young scientists need to improve because statistics also starting from a very basic point of view is necessary in all the step of PLF management. Voluntary, I will show you what, in my opinion, is a really basic kind of statistical analysis, but this kind of statistical analysis is the statistical process control is the base of the possibility to really use all the kind of information from PLF, and also for a new approach for the correct use of more traditional data sources in our farm, because we must remember that statistical process control is widely adopted from 1 century in the industrial, in manufacturing plant. So it is necessary also that at farm level, the farmer and the technicians will be able to manage this basic kind of statistic, but they must remember that the final approach is also the ability to manage big data, to be able to make query on big data and to use correctly big data with the different statistical approach that I show you also in the slide before. About animal farm modeling, in my opinion, is an old matter with new tools, but is important. It's important that young scientists know how to use the large amount of data available, for example, from facial expression, vocalization data, activity data of our animals, olfactory breath analysis, heart rate and heart rate variability analysis, different kind of thermal imaging data that are very useful for welfare assessment, and not only accelerometer data, radio frequency identification, and very important, the non-invasive biomarkers that we can measure, for example, on milk at each milking.
Excuse me, Fabio.
Yeah.
3 minutes left.
Thank you. I go to my conclusion. An important word in PLF is blockchain. Blockchain generally is intended as an instrument for traceability, but in my opinion, it may be something more than traceability, because it is the possibility to link all the animal production chain, starting from the farm to the consumer. And this is very important for the next slide, because the consumer, as a representative of the instance for social sustainability, want to know in real time, and it is possible now to know in real time the origin, all the information about the product he wants to buy. And with, for example, the QR code, it is possible at the supermarket with the correct app to access full information about where and when the animal was raised, fed, processed, and transported and so on. Finally, the possible relationship between PLF adoption and the three pillars of sustainability: economic, environmental, and social. Here you can see there are different overlapping areas for these different kind of sustainability. But in my opinion, at the core, there is the possibility of precision livestock farming tools to manage these overlapping, not only overlapping, but really synergy between the different sustainability, managing with a precision management of animal performance, animal health, and production quantity and quality. Finally, we must remember sustainable animal production systems require profitable production, minimizing environmental and social impact, and undertaking optimal health and welfare for livestock. PLF probably will help us in measuring environmental sustainability, for example, considering that PLF data allow an improvement in nutrient efficiency throughout the animal production chain. Additionally, PLF tools allow the assessment or estimate of some emission from livestock plant. From economic sustainability, that it is the basis for every enterprise. The improved efficiency with PLF may help to attain improved economic result. And the more precise data analysis may help to improve farmer ability to optimize farm management. Finally, social sustainability, recently raised of concern because of the consumer role and the communication media, is important for the attention also for farmers and workers' rights. But at the core of this social sustainability, as I mentioned before, there is animal welfare issues, consumer welfare, and environment protection. So could we better communicate and improve animal welfare or environmental sustainability of our farm with the help of PLF? My conclusion, if possible, PLF, I agree with Bruno Basso about that PLF is a process that is going on and is unavoidable, the diffusion of PLF, and must be supported with adequate scientific and technical knowledge at each level, starting from scientists and technician education. The main challenges, as I mentioned it before, are in acquiring expertise coming from engineering areas. New statistical methods need to be acquired by young animal scientists, both for a better biological data management and for improved farm advising. And a new look at the whole animal production chain, typically from farm to fork, will be necessary to really catch all the opportunity of this approach with PLF. Thank you for the invitation and thank you for your attention.
Thank you very much, Fabio. I just would like to remember the people that, you are allowed to pose questions, but we have a section for discussion at the hand. So please keep your question for the last section, and you can address this question directly to specific speakers or in general to all the speakers. So now is the time for Francesco Morari. Francesco Morari is also an agronomist with a large experience in the area of precision agriculture, soil physics, and environmental sciences. He is a professor at the Department of Agronomy, Food, Natural Resources, Animals, Environment at the University of Padova in Italy, north of Italy. Everybody knows Padova. And also we have a good opportunity to know from here, given his experience as a program coordinator of the master program Sustainable Agriculture. Is it true, Francesco?
Yes.
Okay, so this is, I think, the best person to ask about what is the situation of the education offer in Italy in this specific field. So please, Francesco, the floor is yours. You can start, and you have 20 minutes for your presentation.
Can you see my screen, my presentation?
Yes, we can. Perfect. Okay,
so first of all, let me thank you, Simone, and so Raffaele, for this invitation. So actually, Raffaele asked me to review what is actually the educational offer in Italy. So I was very strict to this command from Raffaele. And so I divided my presentation in 3 different parts. So my presentation, indeed, I would like to answer to 3 different questions. So what are the knowledge, skills, and abilities required to an ideal precision agriculture professional? What is required today to this professional from the precision agriculture market in Italy? And finally, are we doing a good job? I mean, is the educational offer in Italy adequate? So I would like to start with the first question. And so I would like just to show you what is the classical scheme about the precision agriculture. So what are the knowledge required from our graduates, our graduate student, and our professional who go to the field? I mean, knowledge. They have to understand, characterize the field variability. They have to identify the, so let me see if I can maybe, so can you see my mouse when I'm using? So yes, they can identify the abiotic and biotic factor affecting crop variability. After that, they have also to, you know, to suggest and to advise variable rate application recommendation by identifying criteria to manage the source of variability and define also the relationship between what the sensors suggest, measures, and what are the real agriculture input relationships. And after that, they have to perform a decision making. So it means they have to implement a variable rate recommendation. And finally, they have to evaluate if they did a good job, and so in terms of agronomic and economic and environmental outcomes. So, and so in order to, you know, not only to evaluate, but also for the traceability reasons. So this is the knowledge. So, but actually, and this is what we ask to our professional in the field. What are the skills and the abilities? I mean, we have to, for sure, to use, to be able to use GPS receivers, to use sensor, or at least to use proximal and remote sensing data. We must be able to elaborate and map spatial data. For you know, advise the VRI recommendation, for sure they should be able to use DSS or at least models, crop, pest, or disease models. And after that, this is the engineering, you know, requirement. They should be able to set up VRI machines, isobus system, again, guided steering system, and so finally retrieve yield and near infrared sensor information for mapping, and after that, data management and connection. So this is the classical. So I didn't go into detail about, you know, the more engineering aspect. I mean, you know, all the aspect related to, so let's say, to the fleet management and so on. So this is what is mostly required from our students. But actually, this is the traditional approach. There are new concepts you know, are coming up, and you know that there is a transition. So this is, I explain the concept of precision agriculture, but actually the transition goes to the concept of Internet of Things and of, you know, agriculture 0.40. Here, you know, there are just the definitions. I don't want to read it. Don't worry about that. I don't want to in detail, but what I want to explain that the, you know, for agriculture 4.0, you know, you don't look just at the field, at the farm, but everything is interconnected. So it means that new concepts are introduced in our field. Okay, I already say about sensor, about big data, as my colleagues before so explain, or the problem of cloud computing, or the embedded in platform deep learning, and so on, so on, so on. So there are a lot of of information, but also a lot of skills and knowledge which is required to our professional. But do we need really all this kind of information put in just and embedded in one professional, or maybe we need more professionals? So let me explain that. And now the second question is what. So when we come to to what is required from the market, because the situation of the market in Italy is not always, but is not so so advanced. I mean, is advanced for the technologies, but perhaps our farmers are still not able to use this kind of technologies. And indeed, the agriculture 4.0 market is a boiling market in Italy. I mean, in 2017 it was around 100 million euro, and it increased to almost 500 million euro in 2019. Why? Because we had a number of programs, the rural development programs, the national plan, the Industria 4.0, and now that a big flow of money will come with a recovery plan. So the goal of the Ministry of Agriculture was to at least to manage according to the technologies, agriculture 4.0 technology, around the 10% of the UAA, which actually is a pretty far objective, because so according to interesting research of the Polytechnic of Milano, it was in 2020, it was only about the 4% of the UAA. So you see, a very ambitious goals. Again, I asked to my colleague Luigi Sartori to have just few figures about what is the real agriculture market, 4.0 market in Italy. And so Luigi got information from the companies, from the industries, and just to give you a very broad idea, the yield mapping system so includes now about 3,000 combine and silage harvesters. So we cover about the 20% of cereal cultivated areas. But actually, for the new silage harvesters, now they are sold with already mounted yield and near infrared sensors. The GNS steering system so includes about the 99% of tractors. So the data is not very recent, because so according to my colleague, all the new high HP tractors are mounted with steering systems, and also most frequently you can find also in the other tractors. The ISOBUS system is increasing because of the money provided by Industria 4.0, but in 2016 it was about the 10% of the high HP tractors, and it was from 3 to 5% in the other machine. But anyway, the situation is improving. Again, about the control system, even in this case, is improving a lot, because the 60% of the monogerm seeders have isobus instruments in order they allow to exclude the rows. And also the new fertilizer spreaders as isobus DPAE technologies, just to adjust the dose according to the tractor speed. The situation is not so good about the real variable rate application of fertilizer, which is applied only on 200 farms, and it is mostly management zones based, because the sensor based VRAs is not so common. And finally, according about the irrigation VRA, you see that so we have about the gun irrigation system, which is which apply for the 40% remote control system, and only 15, the number 15, have a variable travel speed system. About the irrigation machine, so now in the last 3 years, about 100 machine was sold with variable travel speed system, but only few operating with a full variable irrigation system. So, you know, this is a situation of our market. This is what is requested by the machine. But the situation from the farmer point of view is not, you know, so optimistic. I mean, especially, for example, for the yield mapping system, it is, you know, the combine are so they have this so nice system, which is also operating in a cloud, you know, in a cloud platform, but only a few of the farmer request to you know, to visualize and to, you know, to evaluate their performance in and the management, the effect of the management in the field. Again, I want to show you, this is the point of view of the farmer. I mean, this is the same research of the, I cited before about the carried out by the Polytechnic of Milano. And so they survey about 1,000 farmers, and they ask about the technique which are adopted in the farm. So these are, you know, a little bit weird data, because so you see more or less the technology is related to precision agriculture, traditional precision agriculture methods. Indeed, you see, so they mostly apply control system, precision irrigation, and the soil mapping, and so on. But very few are the, you know, the other technologies related to agriculture 4.0, so related to communication and ICT and so on. So again, just to say that what the market is requiring so far is a traditional precision agriculture professional. Again, so is our education adequate? Are we doing a good job? If you look at so the same research, it seems that we are not doing a good job, especially for the university. Indeed, when the farmers were asked, so which actors can help to improve the knowledge about agriculture 4.0? So you see that the farmers indicated farmers associations and technical media. And only the 7% here, just so indicated the university as an effective actor in, in improving the knowledge about the technology of agriculture 0.40. And again, I was very, very worried because the contractor was only 2%. So especially in Italy, contractors must play a pivotal role in spreading the technologies. They are one of the most important actors. Anyway, I was a little bit worried because when you come to the Farmers Association, usually, at least for our university, they ask to our collaborator to provide to deliver information, and it was a really strange survey, and not expected in its result. Anyway, there is a problem when we want to define a professional in precision agriculture. Here, I want just to report what is a sentence of the guideline for the development of agriculture, precision agriculture in Italy, because so it is clearly stated that it's difficult to to train a professional, because you have to match what are complex technological systems. So I mean sensor, actuators, and remote sensing, with an understanding of agronomic issue and agriculture in a broadest sense. It was the same problem that we had when for 10 years, we ran the Transatlantic Precision Agriculture Consortium, which was, supported by the United States, by the European Union, a consortium between American and European university. So the problem here was to match the, the engineering expertise with agronomic expertise. And indeed, in the end, we were not able to start and to create a precision agriculture master program. But so in the end, we came up with a sustainable agriculture master program. Just because of the problem and to match, the requirement of the different departments. So United States, it's a little bit complex, and yes, to match with our standard. So I'm just coming
Francesco,
to, yeah.
Francesco,
yeah.
You have a few minutes to close.
Okay, I just want to say that according to my vision, the training of the precision agriculture professional must go to different level. To me, it's important that the professional must have an agriculture core. He must understand what is happening in the farm and in the field. There is a second level, which is mostly related to to engineering and geomatics, so geomatics information. And finally, there is a third level, which is most related to our subject, to other topics. But actually, that the professional, maybe it is not necessary that he is very familiar with this topic, but he must communicate with other professionals in order to achieve the goal of a professional, the goal of a precision agriculture farming. So you see that I have a creative precision agriculture God's eye, and with this, I just want to show what is happening in Italy. So what is the educational offer? Just 2 minutes, Simone, if I can. Okay, so we have so far 8 specific programs in precision agriculture, smart agriculture in Italy. The first is the University of Milano. There is a laurea magistrale in Scienze Agrarie, which is a master in agricultural science, with a track in precision agriculture. So more or less, you see, I try to classify the program. You see, they provide information of the first and of the second level. So geomatics, mechanization, precision livestock farming, precision farming, and so on. The second laurea magistrale is offered by Politecnico di Milano, and you see there is also a green circle, because they also provide other other subjects like drones, supply chain management, and so on. So we have in Padova master in GIS, but it's pretty far from precision agriculture. So actually here you see there is a big green circle, because we provide GIS, remote sensing, drones, subjects, and information. There is a new program of the University of Bologna, with a laurea magistrale in precise, sustainable, and sustainable agriculture, with 2 different tracks, animal production and crop production. Okay, we have the famous master in agricoltura di precisione of the Università della Tuscia. Even in this case, you see, this is a master of first level, and you see it disappears the basic information, because it leans toward the second and third level information. There is a new master in agricultura 4.0, and even in this case is a second level master offered by the University of Molise. There is a laurea magistrale in precision livestock farming, but I don't want to steal the work to my previous colleague, so I didn't analyze. And finally, there is a laurea triennale, so it's a bachelor degree offered by the University of Catania. But actually, it is mostly, focused on the information provided, so the basic and the agronomic information, which must be provided to the undergraduate students. I want to finish. And what about the question, the educational offer in Italy? Are we doing a good job or not? So I was surprised by the survey, I told you, because there is a bad perception of a potentially offer from higher education. But in my opinion, they are not always justified, because it is true that we are a little bit behind the schedule, but the relevant number of new programs are encouraging signals, So, and I want also to remember the initiative of single colleagues in different Italian universities that allow to pass to graduate students the fundamental concept and skill on precision agriculture. So I want to recognize the work of Raffaele, and so Bruno, where I was working in Italy, and so many other colleagues. I want also to say that right now we need a classical precision agriculture professional, which must be able to talk to the farmers and educate them with the new technologies. We have a big number of machine, of sensor, and with PA equipment, but farmers cannot, they don't know how to use them. And finally, it is more challenging. It is more challenging training an agriculture 4.0 professional, because we have to bridge different expertise areas, and so actually it will be our work in the next 10 years, I would say. So thank you very much. Again, technology, I want to make a paraphrase of the advertise of Pirelli. So technology is nothing without agronomy. So it's important to remember that we have to talk to the farmers and not to engineers. Thank you very much. I'm sorry that I wasn't.
This is fine. This is fine. Thank you very much, Francesco, also for the many insight about education, which was indeed the main focus of our workshop. So thank you very much, and I hope we can keep discussing this issue together with my colleague. Now is the turn of Mariska van der Voort. So Mariska, are you okay, ready? And she's an economist with a large experience on livestock, of course, coming from the Netherlands, it's livestock, and also precision agriculture, but also big data and the use of big data in our field. Mariska is she's assistant professor at the business economics group of the Wageningen University and Research in the Netherlands. So Mariska, if you are ready, you can start your presentation.
Yes, thank you, Simone. I think you all can see my screen now.
Yes, we can.
And I was also able to unmute myself. Thank you for the introduction, Simone, and thank you also for the invite to talk a little bit more about the economic effects of precision agriculture. In my research, I focus a lot on the value of big data, in which I have a particular interest in data that is generated in the primary sector from digital technologies, and especially quite some focus on precision livestock farming, although I brought up this presentation a little bit more. So in my presentation, I will touch upon the economic value of precision agriculture, which as such is closely connected to digital agriculture. So I will highlight some of the potential value that we have seen or is promised or claimed, but also the challenges that we face to monetize the value of such systems. So the use of digital technologies have caused new concepts to emerge, such as precision farming, smart farming, digital agriculture. So these terms are often used interchange, and I must confess I do that as well. And because of how I'm doing that, I will highlight a little bit quickly on these terms. So precision farming is about the farming and management, the concept that is using the digital technique to monitor and to optimize the agricultural production process. Smart farming is then the specific application of the information and the data technology. So it's really focusing on the access of data and the applications of these data. And in the essence of digital agriculture lies actually the creation of value from the data. So the data collected with, for example, smart farming technologies, digital agriculture goes beyond the presence and the availability of that data and actually is trying to create actionable knowledge, create meaningful added value to the data that is collected. So under the form of digital agriculture, we could think about big data, blockchain, digital twins, artificial intelligence, and so on. And we have seen in the other presentations also those words coming across. So the value that is creation is a result of how well we can use the data, or actually how well we can transform the data into information. So in economics, we talk about an asset when we refer to a resource, which could be in this case data, which has an economic value and then also provide future benefits for a potential user. In consideration of data is unless when you sell the data as a raw version to a third party, it has value. But data on itself, when you do not sell it as a raw version, does not have an economic value. And therewith, we define in economics data most of the times as an intangible asset. So it's an asset which does not have a physical nature. The potential value of the data that is generated within these technologies, that lies when we transform data into information and when we can make decisions with it, or we can improve existing decisions. And that is also the essence of digital agriculture. So when looking in the scientific literature on economics of precision agriculture, economics of digitalization in agriculture, and just looking at the value that lies in the information that we generate from that data, we find that it's hardly been studied in scientific literature. It does not mean as such that digital agriculture has not been studied at all, and we have seen it also in the other presentation, because we find a lot of evidence in literature, but not the quantified economic effects. Those are lacking. We can find economic studies, mainly related to research projects, and we also find it back in commercial settings where new technologies is brought on the market. So with that, we find also quite a number of news articles that are promoting the use of precision agriculture, of digitalization in the agricultural sector, and it claims to have many benefits for the farmer. As such, precision agriculture claims that it could be more productive for the farmer, it could lower operational costs, increases the quality of production, reduces environmental footprint or improve environmental sustainability, improve the labor environment, and making more use of scarce resources. Just some example of claims that are made. These are made on the farm, but it also goes beyond the farm. Benefits that are claimed to, for example, enables improved traceability of agricultural products, which could be of interest for policy, could be of interest for consumers, but also providing transparency for consumers. So it's benefits that are claimed are beyond the primary farm. So although these claims present a positive value, its social economic implications are largely debated. And data as such plays a huge part in it, or a huge role, because farmers are reluctant in sharing their data because of concerns on data ownership and usage. So to do this, there is a lack actually to make those economic analysis, socio-economic implication. There is a lack of data to study it. And what we also see is that users of these systems perceive as having quite, well, smaller benefits or less or, well, more cost, because they are having the idea they are too distant from their need and their possibilities. So as well from social as an economic implications, a lot of gains can be made in doing more research on that. So farmers are interested in precision agriculture, need to choose a systems that serve, or will choose a system that serves their need, but also they are looking for a system that justifies their investment. So the decision for adoption of farmers is heavily based on qualitative information and the perception of the quality of the system, the precision agricultural system they're buying. So the main factors that are influencing adoption in this process are what is the relative advantage, so what is actually the perceived profitability of such systems that I buy, but also what is the compatibility with current farming systems or farming practices. How does it fit in my current management, or how does it link this technology maybe to other technology that I have on the farm? Is it easy to acquire and utilize the technology on the farm? Is there like a kind of a triability for a new option? So is there a way that the innovation can be tested before I really commit to the adoption of the technology? How are the risk, advantages and limitations, are they observable? Yeah? So I can really choose as a farmer what I want. And the social context. So will adopting improve my position as a farmer in the social system? So each of these factors that we saw in the previous slide, in a different extent, they play a role in the adoption. Yeah? So people who adopt, in this case, we talk about farmers who adopt an innovation early, have a different characteristic than people that adopt an innovation in a later moment. For example, what we also can see here in the figure. An innovator is, for example, interested in new ideas, is willing to take risks, is willing to make high investments. Well, if we look at the late majority of people that are adopting systems, those are the people that are much more skeptical, and they will only adopt a technology when it's tried by early majority. So they need a kind of a proof of concept. In the case of precision agriculture, the relative advantage of a system is therefore important. So it's important to know that. And that relative advantage often equates with the economics of the innovation. And that is right away also the challenge, because the economics of many of these precision agricultural systems are uncertain. Well, farmers indicate, on the other hand, that is one of the key factors for adoption. So how could we explain the economic uncertainty that we see? Well, there are several reasons. So one of it is that the economic benefits of the technology of precision agriculture are most of the time indirect and also multifactorial. So when a decision is taken with a system, it not only affects the specific problem where you base your decision on, but in a broader sense, the whole farm management. There is a high degree of uncertainty also in the potential benefits. So most of the time, the problem does not lie in defining what the cost is in investment and maintenance, but the challenge lies in defining what really is the benefit of the system. And at last, what we see is that the decision to take with the implementation of new technology, so the decision support information, is not always clear or is lacking in systems. So without knowing what kind of decisions to take with the system, it hampers the adoptions. And sometimes these new technology even focus on problems that a farmer is even not aware of, that there was a problem or a decision problem on that specific point that is addressed. So when we study the innovation, it's relevant to look at the future benefits and to take uncertainties into account when looking at the adoption. And a paper that has been looking at the effect of adoption on the investment is done by Rutte et al. In 2018. And the question they raise, the question they raise in their study is, am I going to invest at this moment, or is it better to wait? So in this matter, the Rutte looks at the adoption of a sensor in dairy farming. So for some sensors, not much progress can be expected because the technology has already made enormous progress in recent years. Whereas there are other sensors that only have recently been introduced on the market, and we are expecting a lot of progress still can be made with those sensors. In the table that you see here in my slide, it gives a short summary of the results of the study. And I'm not going to dive too much in all the details on how they performed it in this case. What do we see here? Well, on the left-hand side, it shows two investments. It shows automatic estrus detection and automatic body condition scoring. It shows us the cost of the investment of the sensor, and it also presents the net present value. So the difference between the cash inflows and the cash outflows. On the top of the table, we see the results of the investment when we invest at this moment, but we also see the cost of the investment when we postpone the investment. And then we see the difference. In case and by the way, the postponing the investment was postponing the investment with five years. So in case we would invest in automatic estrus detection, so that's the first sensor, investing now is much more of interest than to wait for 5 years. And automatic estrus detection is also a sensor which is already for a long time on the market. Well, what we see in automatic body condition scoring is that actually postponing the investment is of much more interest. And this implies that just from an economic point of view, it's rational for a farmer to postpone the investment in body condition scoring. In this study, we see that how mature a sensor is could, in fact, when it's of more interest to invest and when to wait. And in this case, if a technology is not that long on the market, a lot of progress can be made. Postponing an investment could be of interest from an economic point of view. So let us have a look at two examples from literature about the economic effects. I talked about the claims, the possible claims, but let's have a look at scientific literature or studies that have been done. So this is the latest publication that I found, which shows the economics of precision agriculture in relation to livestock production. And what they have been doing in this study is they looked at the difference of productivity. The productivity is estimated in relation to farmers that adopt a technology and those that do not. So this study measured herd productivity index defined as a 305-day average milk use per cow per herd. So that's what they looked at as productivity. Whether a precision technology improves the production or productivity level of the dairy farmer or not after introduction, that is what has been studied. And however, if there is an effect, that effect could also be affected by other changes. So for example, the training of the farm and the new management. So that's multifactorial. So it's not only about implementing the sensor, but actually more factors could affect if there is a benefit or not, or improved productivity. So therefore what they did, they actually, the training personnel of new management techniques, they fixed those effects. They grouped farmers in three levels by application of sensors. So sensors that are in relation to reproduction, sensors in relation to milk production, and disease surveillance. So what they found in this study, looking at the 305 days average milk yield per cow, is that this is higher for those farmers that adopt the technologies than for farmers that do not. So the result shows there is a positive effect of using any kind of sensor on farm productivity index. What they also observed is that younger farmers are more prone to introduce an innovation in farming, which is interesting, and that is also what we see in several other farms, that they're most of the time also more willing to adopt or maybe more risk takers. So we see that precision agriculture could improve farm productivity through to better management of the herd, which also suggests that the adoption of the technology could improve productivity. What is nice in to see in this study is that the authors in the end were wondering why, if we see this efficiency improvement, why not all farmers do adopt these technologies? Well, what is not taken into account is the cost of investment and the cost for maintenance. So that was left out of this study. And besides that is that implementing a technology could also result in changes in the management, or even maybe requires newer management. So there are more factors that are hampering that adoption, which relates back to some slides previous that I showed you.
And Mariska,
yeah,
just inform you have 3 minutes left.
Oh, okay. Well, what I will do, I'm going to skip this this slide. So this was a slide on the economic benefits of precision agriculture in grain farms, and also shortly in this study we see an economic improvement. So we see some benefits due to the implementation of precision agriculture grain farm in Australian farms. what they also showed in this study is that besides that the economic benefits that we have and that we're able to make more kind of tangible or monetize in this study, we also see in this study that there are more things that come in play for farmers to adopt the technology. Because the benefits that they also see is, for example, increased knowledge, being more confident of the way they apply fertilizer, but also they become better in crop weed and control. So important in this study is also to indicate that farmers were highly literated in the use of computers and GPS technologies and to keep good farm records. So we see is the ability of a farmer to being able to work with computers and work data has an effect on the adoption, but also on the successful use and therefore gaining economic benefits from precision agriculture. So the net economic benefits that are derived are very specific from farm to farm. So they are highly situational. But besides that, we see potential benefits of precision agriculture on the primary production level. There are also many benefits that might be gained downstream and upstream in the food chain. So, for example, farm advisors, but also suppliers of farm equipment have been working most of the time in the past individually with farmers. And what we see nowadays is in their business, they are working more on an integrated level. There is a lot of interaction between the input supply market and partnerships between farms and suppliers, which could lead to potential benefits. So for example, we see partnerships between Bayer and John Deere, between the Laval and Uniform Agri, but we also see breed and seed companies buying up software companies. So the reason why we see this collaboration rising is because data that is collected by one party could also be of interest to other parties. Indirectly, digitalization of the agriculture sector is also expected to benefit consumers, so increasing food safety and transparency. And at last, we also expect that the policy is also benefiting from this, because data more and more is collected on many different places in the agriculture sector, and with that they could have better insight in what is happening in the chain, or what is happening in case of a food crisis, being much more easily to trace back what has happened, but also the policy they set out for farmers could be made maybe more farm specific. So really make a policy custom made where farmers can prove how they comply the rule in their own way instead of imposing rules by policy and indicating how farmers should achieve those rules. Because we were talking today about education, I wanted to highlight a little bit about economics and social sciences and how we could integrate that within precision agriculture, within the digital transformation. And we have seen a lot of progress is made, but we can still make quite some progress. And this has not per se to do to only the research where we can make progress, but also in the education of our students and mainly our PhD researchers. So good communication and understanding, and the previous speaker already indicated that or touched up in that a little bit, is that understanding each other from different fields of science is a very important element in taking the next step and improve the implementations of digital agriculture and the benefits from it. So we notice, for example, in project that learning to understand each other from different scientific fields maybe even take the most of the time in a project. So one of the ways that we are working on within the project in our group is to see if we can provide a multidisciplinary education for students for PhD research. So for example, teach biology students with data analytical skills, or teach the data analytics with more biological skills. And as something that I'm working on personally is teaching economic students with more data-driven skill, or at least how can I, how do you say that? How can I understand and implicate the data? In Wageningen, since last year, we also offer a specialization in data sciences. And that is a data science specialization specifically to life science and agricultural sector. And within that data sciences, we focus on, in our group, on the digital agriculture and how it could improve decision making and have an economic implication. So the future research agenda provides ample scope for a future interdisciplinary and transdisciplinary science on precision farming, smart farming, digital agriculture. So one of the contributions I think that from an economic point of view that we can deliver is not only to look at the situations that we have done in the past, but also going to look forward and to study the potential of precision agriculture before the development of the technology, and to deliver a kind of an economic proof of concept. So actually performing a more ex-ante analysis. And with that, I like to finalize my presentation, and thank you for your attention.
Thank you very much, Mariska. Thank you for this point of view of the economic analysis. So again, then we will have a discussion section after Raffaele's presentation, and so please keep your question, record your question, and we will go to discussion section very soon. So now is the turn of Raffaele. Well, as you know, he's an agronomist with a large experience in field, precision of agriculture, remote sensing, crop modeling too. And that's why he's the main organizer of the teams. And he's a professor at our Department of Agriculture and Forest Science. And
okay, hello everybody. Can you see my slides?
Yes, we can.
Okay, so I will try to be short because we've taken. It's been a very interesting afternoon, I think, with very, very interesting presentations. So my role now was just to provide a quick overview of the research on these topics. This is carried out within our department because this is part of this event is part of the project that was mentioned by the director earlier in the afternoon. So I was just quickly looking at the Scopus and Web of Science databases to have an idea of what the trend in papers published on these topics by members of our university and our department. And so I was happy to see that there is quite a sharp increase in later years. So the number of colleagues who are starting and developing research linked to digital or precision agriculture or smart agriculture. Although my survey was very quick and very limited, so of course, but I think it shows clearly that there is an increasing interest in these topics by our colleagues. So just to introduce very shortly the kind of research that, for example, my group carries out is basically on the use of remote sensing, the quantitative use of remote sensing for improving the monitoring of soil and crop properties. And this is for, of course, linked in a way to understand better how to manage the agronomic, to carry out better agronomic management, in particular of fertilization. So developing precision fertilization approaches mostly based on satellite data. And we also have been working with UAV data, especially for high resolution and hyperspectral data and for precision weed management. There's also a very interesting and important project that has been going on for the last few years, carried out by our colleagues, who are working more on tree crops, especially on, in particular, on hazelnuts. So this is a project that involves other universities, also people working on robotics, and it's developing a concept of a control system, or called the SCADA control system, which integrates a lot of sensor data, and then into the system will allow the decision support and the actuation of farm operation. And there is a quite very interesting robotics component in this project that has been tested on hazelnuts, which is a very important crop, so you know. And there is an interest of the industry. You see that Ferrero is one of the partners of the project. There is also a group of soil scientists headed by Simone Priori, working a lot on proximal sensing, so digital soil mapping for having rapid methods to obtain information on soil properties, which is very, very important, of course, for precision farming applications. And there is also, as was mentioned before, precision livestock farming is also a very advanced sector, and my colleagues in the Animal Science Research Group, especially Umberto Bernabucci and colleagues, are working on the detection of by using sensors, detection especially of the quality of feedstock of livestock production to improve the feeding and to decrease the cost of monitoring feed quality of livestock. So this is also some kind of research is carried out. Then there is also research carried out by our colleagues in the plant protection, plant pathology field, who are using, for example, in a project that we also had together, they are using UAV data for improving the monitoring of plant diseases. In particular, here they were studying Fusarium head blight, which is an important disease of wheat, and has been. We have seen some good results also with the monitor from thermal and RGB cameras. Another group who is working also in some topics related to digital agriculture, the group of our colleagues of agricultural engineering, and they are especially focusing on the safety of workers in agriculture by adopting smart system and feed control system, which is also a very important topic. Also, colleagues in forestry are using technology. So I would say, like there is this field of precision forestry, and for example, GIS and GNSS systems to study how to optimize the skip trade patterns for forest operations is a project that have been carried out recently. And also my colleague Paolo Danieli has been working on a project on precision beekeeping by using sensor in beehives and monitoring the behavior of the bees with the interesting technology. So also this sector is improving and is changing with new technologies. Also, again, on tree crops, there is possibilities to use sensors like these new sensors to study the quality of fruit, like also olive crops, and this is a research carried out by Professor Muller. And finally, also in addition to the research, the master, this is not related to research, but has been mentioned since we have been talking about education. So I just wanted to mention the master in precision agriculture that has been is currently going on and involves several students and they will do their project work. And also, it is a way that we are trying to contribute to the development of skills in this area. So just to conclude very quickly, what we have heard today is that there is the inclusion of technologies like sensor ICT technology in the farm sector is really rapidly increasing, and it's unavoidable. So it's something that we have to deal with. And in order to make the best of what is going on, the training and the people that must have a multidisciplinary skills. So the background that they have, it's really that they need to have an understanding of technologies, so engineering, as well as the agricultural system, so agronomics, so or in case animal science. So this is it's quite complex to match together, has been already stressed by the previous colleagues. It's also a very rapidly evolving field. So the reason also I was presenting research is because education in this area, of course, must be backed by an active research, because technology, we know technology are changing so fast. In particular, we are now in the period of paradigm change caused by the artificial intelligence revolution. So the data science skills are really important, because we need to understand how the algorithms work in order not to be just passive users of this technology. And in general, maybe some points that we can also discuss is that there are sensitive issues on data ownership that they have mentioned, I think, also by Mariska. And this is something that is becoming increasingly important, because many dealers, many companies are developing cloud-based services. So the data are going to the cloud, and then the farmer doesn't know really what happens with their own data. And in general, I would say that sustainability should be the main focus for the the implementation of these technologies in the farm area. Also, this is what I think would, of course, justify the investment, or the public investment in the that has been mentioned by national and now European programs for that really support the adoption of these technologies. But apart from this, public and funding programs, we know that the adoption, as Mariska also said, that it's really driven by the economics and the ease of use. So there is something that we need to take that into account, because it's not only what can happen is that farmers have now the support, the financial support to buy these technologies, but it could be that they can have the technology but don't use them really at their maximum level, so they just underuse the technologies available if they really don't understand and really don't see the benefits for themselves, especially for making life easier. So I think one of the best reasons for the adoption of a technology is that it makes the life easier and the operations easier for the farmers. So this is what really would, I think, encourage the adoption of these technologies. Okay, so I hope now that there could be some discussions. So I leave the floor to Simone.
Yeah, thank you, Raffaele, for this overview of the different activities. Yes, now thank you everybody. Sorry for not letting the question after each presentation, but otherwise, I mean, I was afraid that we didn't have time to finish. Okay, now is the time to pose questions. Already there are some questions. I've seen one question. So while you are, and maybe you can raise your hand and ask the question directly, speaking, if you like. there was a question, I think, addressed to Bruno Basso that was asking, which is the most used technology in the US, satellite images or drone images?
Well, it depends on the system that we're looking at. Let's say drones are suddenly becoming popular, and farming in the US is actually witnessing an interesting change because of new generation, younger generation being present on the farm, and actually because of the technology. So with a lot of the farmers that I collaborate with, there is always a younger, son that is willing to, it's getting the license and it's flying, and it's becoming popular. Surprisingly, I mean, it's not a case, anecdotal. Don't know the statistics, obviously. So companies selling images, drone images to farmers is less popular. So the farmers themselves are getting equipped with drone imagery, and they have fun doing that. By comparison, satellite imagery it's a complicated business. So you have to do all the processing, correction. And so that level of statistics heavily relies on the collaboration that a group or a commodity would have with either a university or a research institution. So in my case, I work closely with the National Corn Growers Association. And so basically develop this, as you have seen, this concept of stability map and be able to, see the variability on the farm. I was able to patent this technology. It was acquired by a company that provides these actually at no cost, because the business is more in the carbon farming. So there isn't a straight answer. I couldn't be able to tell, but there are complexity on both worlds. I think the novelty is the fact that the young generation is helping the transition on a farm.
Thank you. I don't know if there are questions. Otherwise, in the meantime, please ask questions. We have a very distinguished speaker, so it's a good opportunity to raise your hand and ask a question. So don't be shy. You can write if you have, if you don't want to speak. I have a question, which is a general comment. It's not a question. It's coming from the final conclusion by Raffaele, that I think we didn't stress too much about the sustainability issue. I mean, this is a major benefit of the technology, in my opinion. Okay, of course, it's very difficult to quantify from an economic perspective, and I think myself and Mariska know how difficult it is to evaluate environmental services, but this is very important, very important. Now, there is huge support for agri-environmental measures in the EU, for example. And so I believe that this kind of techniques in the future will be very useful to develop more targeted even new policies for improving and for rewarding the environmental benefit that farmer can provide. Do you have any inside experience or any idea of what is going on in this area? I mean, I don't know, is the government, for example, in the US, using these kind of technologies?
I can certainly bring the example of the US, but I mean, you have, I always think that Europe is a little bit ahead of the game with the Green New Deal that's really focused on sustainability and even though it's not directly linked to technology, but it's basically the means to reach that level of sustainability. In the US, yeah, there is a major turmoil. Even last night, the President Biden mentioned the word of cover crops and be able to pay farmers to do regenerative practices and stuff like that. So what we have shown actually, and it obviously was a short presentation, but the areas that they're not productive because of the profitability analysis, farmers are beginning to resonate that and starting to be willing to put those land aside for biodiversity and ecosystem based, as long as they get incentivized. So the new administration is pushing for incentives based on ecosystem services. They still only voluntary, but they're basically becoming more popular in the context of carbon farming. I mean, you probably hear a lot that farmers are starting to getting paid for carbon credits that they are sequestered. And again, both whether it's variable rate, but rather the whole digital lag that was clearly presented today, I think that's the biggest benefit. But as you well know, we have to be willing to pay for it. And the farmers should not be just the one bearing the total cost, because they basically are at the front line and bearing the cost and providing the food. I have brutal conversation with farmers, but at the same time, you got to really also look after them, because they are the ones, you and I all here have zero risk in this conversation, and they're not risk neutral. So they make a decision based on, something is, who would have a job that depends on climate, very volatile and risky. And so incentives is a way to do it. The other thing, and I'll conclude, is that the food system is becoming the driver of the change, which means all the companies, the CPGs, consumer packaged good companies or even processing like Cargill or Bunge, or they basically Walmart, they select farmer based on sustainable practices. And the ones that adopt sustainable practices are the ones also more well informed about technologies, and they use yield mapping and all the data storage and analytics. And so an indirect way of incentivizing is not necessarily through policy, but it's also through the changes in the food system and the transparency that the consumer demands. So that's very equivalent globally, mostly in high income country. I work a lot in developing countries as well, trying to bring the technology and avoiding mistakes made here. But that's totally different discussion over there, because they need to boost.
Yeah, it's another very important and useful.
Sustainability comes secondary there. I mean,
There is
long term.
A couple of questions written in the chat. One is, I would like to know if someone knows about benefit related to precision agriculture in peri-urban areas. I don't know why peri-urban areas is the focus.
Yeah. Well, not necessarily
of the band. I mean, the facility to access to the broadband.
I mean, peri-urban are defined, maybe here within 40 miles of big cities, and the direct. But it isn't necessarily a precision agricultural, discussion to have, because these areas are also not. I mean, they're more direct consumption, so people selling stuff for a direct market, and so there isn't necessarily a link. The link is more on the digital, be able to sell on the internet or do things more like digital logistics than managing for variability. So it's more. Go ahead.
Yeah, and I think adding to that, Bruno, also being able to transparent to consumers. So
yes,
using digitalization to show, okay, this is what I'm doing, and like a proof of concept what I'm doing on the farm, and that's why I'm having a higher price for my products.
Right.
To reach the consumer.
And started in animal production, the transparency for the consumer is very important, namely about animal welfare and drugs use, namely antibiotics. So I have a specific project on this topic because it is very important. I mean, in Italy, in our region, it's very important if we will able to demonstrate in an objective way with objectively recorded data if we are able to reduce the use of antibiotics, essentially by more important prevention, because PLF, we know that PLF tools namely in dairy system, it is really able to help us in detect very early problem, very early symptoms that give us the opportunity to reduce the use of antibiotic by a very quick response with the animal, with the separation of the animal, with the ability to remove the causes.
Okay, thanks. I think Bruno has a question.
Yeah, just a quick question for Francesco, who I enjoyed very much your talk. What was your surprise with the survey? If I understood correctly, basically the Farmer Association get the request, they called you, you give the information, and then at the end it resulted as it came from them?
Not in this way. So the farmer associations, so they organize, seminars, meetings just to improve their knowledge, but they don't have their own techniques, just for running the seminars and so on. So they ask to our collaborators just to provide the information and just to organize the seminars. And so it's clear that there is a lack of knowledge about the technology, how to use them, and so on. So I was surprised because the university was just in the low rank. But so actually, honestly, I don't think we are so bad, Bruno. So I mean, we have worked for so many years on the topic. I think it's just a problem of reorganize of the information. This is what we are doing, just starting with new programs, and so I think we should be able to catch up, I think.
Yeah. Well, one thing as a difference with the US, the universities are not really designed to provide extension in Italy. I mean, you provide education, you provide advancement of sciences, and here we have dedicated people that they have a faculty appointment, but they don't teach, they don't do research. They do the same thing. They come to me and says, can you give me all the results? I'll package it, I'll organize it, and they go. So we see very similar things. It says, the information comes from extension, but extension doesn't do research themselves. They come to us and they do that. It's okay. We don't have to get the glory. What I like, though, is the proactive movement of organizing the event and, pushing for that, which we wouldn't be able to do very much, being so busy and getting pulled in so many directions. So I think the commodities, the Farmers Association need to be, kudos to them for organizing these events, because I think it's only through a multidisciplinary, both extension and science that we can move the needle forward.
I have a question for you, Bruno.
Please.
But it's different because now is a hot topic here in Italy. What is the position in US about the agro-photovoltaic?
Oh, okay.
Because it will be, I know I'm very worried about that, because you don't have risk. The farmer, avoid to have risk because he's planting photovoltaic, panels. So I just wanted to know what is your position.
Yeah, no, it's a no starter here. There is no photovoltaic on agricultural fields. Studies have shown that in places like the southwest of the US, Arizona, and they could provide benefits of, shading the crops and in a sense of a very hot environment, and some positive aspect, but very anecdotal. What is more popular are wind turbines on the edges of fields. So if you drive outside Chicagoland, it's all the field. The good thing, at least about that, is they're not converting entire fields. The companies require to have the windmill next to the edges by the road. So I'm actually working on identifying areas where unproductive land could be allocated to alternative land use. I think the biggest discussion on bioenergy, Francesco, is on bioenergy from crops. So basically switchgrass, miscanthus, industrial crops. There is no market still, but DOE is pushing heavily, because if you think 40% of the maize, the corn in the US goes for bioethanol. The other 40% goes for livestock. So when they say, feeding the world, yeah, sure. I mean, for people that eat meat or they use ethanol in their cars. So there is a pretty drastic conversation about land use. So no solar panels discussion on agricultural fields here.
So sorry, Simone, I went, maybe
no problem. No problem.
You can just not have a recording, so you can.
Oh, no problem. There's, I think, a quite interesting question from a young person. Why should a young guy or girl should choose to specialize in precision agriculture instead of in other sustainable techniques?
Yeah, just a second, please. As a side notice, I will allow to talk Elisa, since I've seen many questions from her. So when you ask a question and Simone will read it, I will unmute your microphone. If you want to add something, you are welcome.
Yes, thank you.
Thank you. Can you hear me?
Yes,
yeah.
We can.
Yeah. So yeah, I'm a younger, and I'm graduating in a master in innovation and sustainability, and I'm following a project in precision agriculture, which is a project in a peri-urban area. That's why I was asking, and I can't find much data. That's why I was asking. And also, I don't know, I would like to understand in which sector I would like to specialize, because actually I'm not 100% sure about what to do next, even if, I mean, I like the agriculture sector a lot and the sustainable food sector a lot, but I don't know where to look at. So I was asking this question to have clearest ideas.
I personally believe that Francesco is the best person for answering the question of because of the experience with your program. I mean, with the master program.
So I mean, so to me, so I don't want to convince you, but so to me, in the precision agriculture process, there is all the agriculture. So I mean, you have to understand what is happening in your field. So you have the agronomy, you have soil science, you have the disease management and so on. And so you are really you can really have the control of agronomic processes in your field, and then you can add the technologies. So you have both. So in both sides you have both advantages, advantages, and so I think it will be provide synergies and benefits, and you can become a very advanced professional. From my personal, this is my personal point of view about the advantages. So
yeah, sorry, yeah, I forgot to tell you that the master is an economic master because it's in management anyway.
Yeah.
And I don't have much knowledge about
Agronomy.
Yeah, exactly. And also technologies. It's just, I'm approaching to it with the project that I'm following, but I am an economist anyway, so it's hard to approach with only management basics.
Well, it will be a big change, of course, challenging, of course.
Yeah, but it's interesting. So thank you for the seminar of today.
Yes, but maybe I can add a few words. It's just maybe you've heard there is really a lack of economic studies on the adoption, on the the advantages and the benefits, cost benefits analysis of the adoption of this technology of precision agriculture, and especially because it's understood that in many instances these technologies provide benefits not just limited to the farm, but like environmental benefits. You call it how do you call it, you economist?
Externalities.
Externalities, exactly, externalities. So there is really a need to carry out this kind of studies because I know there is a lack at the moment. And you're mentioning in your question why specialize in precision agriculture and in general in these technologies instead of other sustainable techniques. I would say that because by using technology, you really have the chance of knowing much better what is happening in the field. Because when you take decision, you want to adopt a more sustainable way of producing. That is really what is needed. And in order to do that, you need to know a lot better what is happening. And the technologies, the sensors that we have now really allow in an unprecedented way to monitor what is happening. It's still not enough because there are so many things that happen inside a field, inside a farm, inside the soil is really not even enough. But it's a big step that we are doing in improving the knowledge of what is happening. And only based on this kind of decision, I think, we can take the best decision, best choices in order to have improved the sustainability of the production systems. This is my opinion.
Yes, and if I can add, using the economic jargon, you will be an innovator. Okay, so you will gain, from this. I mean, given this probably is going to increase the role of this kind of technologies. I mean, stepping in first can be a good advantage for your career.
And I'd like to add something to that, although I don't know the system in Italy, but I think an interesting development within agricultural sciences is, or digital agriculture is a digital twin. And I think Bruno also highlighted shortly the digital twin, which I think is a very interesting development to follow up, which is linking all kinds of different sciences group together. But is also maybe in the future covering the problem on the data which is lacking in these peri-urban urban areas. So yeah, Elisa, maybe that's also something to have a look in and to make up your decision where to focus on.
Thank you very much for your answers. That were very interesting, and I'll take a decision soon. Thank you.
Good. So any other
I see there is another question in the questions and answers section from Davide.
Thank you, Mas. This is a specific question from Davide Tahani. to Francesco Morari again. Quite practical. In which part of Italy it's easier to find job as a PA professional?
Good question. I would say, so honestly, you know, there is a market here in North Italy, and so that, you know, it's you know, it could be convenient. So in case you wanted to come to work, for example, you know, there are big companies who now needs to train the farmers. So what Bruno said about United States, in our case, are the companies who need to train the farmers. So I think, so especially for, you know, so in this case, so there is a market, and it's still a growing market. So I think, especially now, after the recovery fund, we will create a lot of job, you know, and especially for digitalization, but also for the replacement of machinery. So in that case, I'm pretty confident. I don't know. I have to ask to Raffaele for the center Italy. I don't know. I don't have any idea about that.
Okay. Massimo, do we have any other question?
I don't see any other, but I have one.
Yes, please.
And it's a question to all the modelers, because I've heard Fabio that I think described really well two kinds of models. So there are the data-driven models and the process-based models. So data-driven is what we call machine learning and so on. And maybe he said something like, sometimes it can be a little obscure, while process-based models, like, I don't know, water balance or something like that, are something that requires you to know, to simulate and to simplify the agricultural system. So my question is, I've seen data-driven models, machine learning getting more and more relevant in these times. Are they going to replace process-based models, or do we still need them? I mean, are we wasting the time by studying the agricultural systems and trying to summarize it through a model? Or there is something that data-driven models can't do, and that crop models or animal models, process-based, are better at doing?
Oh,
I can you go ahead, Fabio, but I can certainly add stuff.
I have a short answer. I see that with my colleague that are experts in animal modeling, they say that they say in published paper that the future will be a mix of the system, because I really appreciate statistical approach, obviously, but as human and for our better management of our resources, we need to understand what we are doing. I respect machine learning, but we need to understand why we obtain a result, because it is necessary to also to teach the reason to young students, to teach why we obtain this model and why they perform good. I can conclude with a joke of my old professor. If you analyze the data of many farms in Italy, you will find a high significant correlation between the yield number and some performance of the animal. Yeah, is an excellent statistic, but it's not, if you put a higher number on the hair of a cow, you will not obtain an improved performance. You must check that the system to put the ear tag is related to the time. So one day you will show that the problem will reverse, we start again. So this is just a joke, but just to understand that the mix is obviously, in my opinion, the correct answer.
Thank you.
So that's a relevant question, Massimo. We're about to publish a paper where on the entire Midwest, we train the machine learning models using crop models, which was validated. So the main limitation of machine learning models is, or any statistical models, you rely on good quality data, which you don't often have, and the relationship is not always transferable. So in order to cover a spatial extent, you would have to have studies of high quality and still hope that the relation holds when you project outside the data. A process-based model has the advantage of giving you the reasons. And so in a long story of Fabio, it's causation is not correlation is not causation. So that's basically, and so the value of machine learning is the speed of, now we can run at subfield resolution and estimation in about 10 minutes. If you were to run the crop models, it can take, at that resolution, it will take much, much longer time, and you will still have to make assumptions about things. So the meta model and the ensemble of different models and different machine learning models is the way to do it, and combining them. So that's basically what the paper is going to describe, how a meta model was formed by linking ML with crop models.
Thank you.
Totally agree.
Yes, I think maybe also I really agree with what Bruno said. Basically, crop models are they contain the results of a generalization process. So they're the result of studies and carried out in different conditions until the scientists they decide this process can be described by this kind of equation that can be more or less generally applied. Whereas if you apply machine learning models or these techniques, they are entirely based on the data you feed them to. So unless you feed them with all the possible combinations that are really infinite, so you would have a model which represents just the data that are given to them. So I think the generalization quality of the process-based model is what would make them more, give them an advantage in case you want to apply to some situation, unless you have tons and tons of data that represent whatever conditions you can find.
Yeah, the other value is the process-based model they can fill the gaps on data that they weren't studied. So they can improve even the ML on local condition if you run a model. So there's a paper in Environmental Research Letters of how to improve estimation of N2O emissions using ML coupled with a crop model that we just published. So it is the direction, the combination of the two, but we all covered pretty much said the same thing,
Thank you all.
Okay, guys, I think it's more or less we have finished question. No more question from the floor, from audience, sorry. So this is, I can just say that I appreciated very much the workshop, very interesting, I learned a lot. And I'm approaching this topic, and thanks everybody for the contribution. And I very much like the international kind of flavor of this workshop, and I hope that will be opportunity very soon to develop something together. You know, I think there is a quite huge demand for this kind of events. So I'm just putting on the table one very strange proposal, which is, why not thinking about sort of summer or winter school in the coming years?
That sounds good.
Yeah,
That sounds as a very good plan.
our university can support very much this kind of activity. Okay, so
You got
let's
the
stay.
recovery plan money now. You can spend them. So you have the recovery plan money.
Well, yeah, so we can think about, and maybe you can think about this, and we can get in touch in future. So thank you very much to everybody. Thank you, Raffaele,
Good to
for
see you all.
organizing the event,
Thank you.
and hope to see you also in person very soon.
Bye.
Thank you.
Thank you.
Bye.
Ciao Raffaele, ciao Francesco.
Thank you.
Ciao, ciao,
Ciao, Massimo.
Ciao.
Thanks to